In this video, we'll discuss and learn the process and critique of a statistical study. I have two big points I want to bring up that I want to talk about. The first is understanding the process so that we can ask good questions or at least identify issues where the process may be at fault. And then I want to look at questioning the questions that really critique a study, that maybe ask good probing questions to generate a helpful and beneficial conversation. So today is a very cynical video focusing on critiquing studies, but not just looking at a claim and saying, I don't like it, push it away, but instead to understand good critiques of studies that maybe, again, don't completely cancel out a study, but maybe one that hopefully asks some good, important questions. Let's dive in. So the process. So it's important that we understand the statistical studies usually follow this typical strategy that first we will need to design the study. Now, in order to do that, we have to build up to this point. That is, we need to figure out what question is being asked, and then we can kind of determine how to answer that. So what is the question? And that's kind of the guiding force here. Depending on the question, that's going to dictate our population or the group that we're interested in. It's also going to help us decide, again, variable or variables that we might be studying. Just a real quick recap here. There are different variables that we're interested in studying. There's the qualitative type, the categorical nature. There's the quantitative continuous. These are variables which are usually measured. There we go. And there's also quantitative discrete. These are variables which are usually simply counted. And the reason why the variable breakdown is important is because depending on the simplicity of our variables, again, qualitative being the most simple category like questions, all the way down to continuous are very you handle them differently, and so they often require different descriptive statistics that we'll mention here in a minute. Especially, it needs to determine my variables on whether or not I should use an observational study or an experimental design. Just to highlight the difference between these, observations, very inexpensive, cheap, easy to do. Experimental design is really only if we're trying to show any kind of causation, any kind of causality. That's where I need to look into an experimental design. So any kind of causality, that's what we're interested in. Once I have the design of the study figured out, well, then I can progress on to collecting that data. And if it's an observation, this is a very cheap process and one that we can readily do. But of course, you could imagine if I had a table of 1,000 pieces of data, 1,000 pieces of data, it gets very nonsensical very quickly. So we need a way to organize that data. Again, if we have quantitative data, oftentimes we can talk about a mean or an average to compute, right? How can I summarize that data into a meaningful number for us to use? And then once I've done those three steps, well, now it's time to actually make those inferences and hopefully justify or answer the question that was being asked. Analyze the data to answer the question. So design a study, depending on your setup. Talked about those characteristics and variables there. Then collect the data, organize the data, and lastly, analyze it. So there's the process. How can those bring up interesting questions that we can ask? Let's dive in. So we're going to focus on the design of the study. And first we need to understand identifying these three components: the question, population, and variables. Example 11 here. Neurologists want to study the effect of vitamin C on nerve disorders. The goal of the study is to see if taking an intravenous dose of vitamin C will reduce the amount of nerve pain reported by patients. Identify the question, population of interest, and the variables in the study. So the big question that's being asked is, we'll say, does vitamin C, in particular, intravenous doses, affect nerve pain? We're hopefully affecting it decreases, but we'll just be as generic as possible. That's our big question. Is vitamin C affect nerve pain? And the big question, especially as it gets to observational or experimental design, is, are we looking for some kind of causality? Here we say affect. Again, usually that means that we're looking for an experimental design. A little bonus for us. Let's see if we can identify the population at play Again, this is like what group you're interested in. Well, I can't just talk to the general population because they might not suffer from nerve pain. So I want, particularly, my population needs to be people who suffer nerve pain. Right, so that's my population, my group. If I wanted to get specific, I could talk about a certain ethnicity or race, and I can talk to those individuals. I could talk to elderly people, right? I could highlight a certain group if that's what I'm more interested in targeting. So it's important that when we frame our question, that the population is defined in there as well. What are the variables at play? This is usually going to be in your question somewhere. I should have two variables here because we're talking about a causal relationship. That we should have our dose of vitamin C, yes, and I'll write here amount of nerve pain, right, measured in some particular scale. So these are the characteristics of the process or the design of the study. Good. So sampling is a necessary evil, and the reason why I call it an evil, because sampling is not perfect. Oftentimes we would like to, it'd be the best case scenario. If I could somehow get a census, that's when you talk to everyone, because then I get, well, the actual number. There'd be no real need to argue for the study because it's like, hey, look, I talked to everybody and everybody reported this same instance or situation happening. But again, very rare, which is why sampling is often needed. There are a couple of different effects that may influence the process of a study. Placebo is a great one to talk about. I'll start this one for you. Many of you have probably heard of placebo before. It's essentially when we do a study, when there is no intrinsic beneficial elements in this placebo. Oftentimes, if you're getting injected, they might inject you with a little bit of saline, a little bit of salt water that has no effect on your body. It might feel a little cool, just like some kind of vaccine or something else that they may be injecting to you may feel. But there's a really fun conversation to have, so it's something I want to highlight for you. For instance, in vaccine trials and cancer treatments, it brings up a great ethical dilemma. And so it's important to understand the process and critiquing it. But again, just because there is a critique doesn't necessarily invalidate the study. Let me mention these two real quick. So with vaccine trials and cancers, oftentimes there's this big ethical dilemma between a placebo, which again does nothing for nobody, versus we call it an active control. That's a fun little term if you ever want to get a good Google in there. And what an active control is look, instead of giving you salt water or something that has no intrinsic beneficial effects, you can imagine for cancer patients, I don't want to just give these people nothing. Instead, I have two things. I have my new drug that I'm hoping is going to benefit these people and help them recover or have a better state of life. So new drug. And then instead of giving them nothing, I'll give them the next best thing. Other than my drug, I'll give them some kind of active control. So right here, next best treatment, not thing. I'll say treatment. Treatment versus new drug. And so placebo is the golden standard. That's oftentimes what's put out there, especially if you want to compare literally this new drug that can save you versus doing nothing at all. But oftentimes you run into a huge ethical dilemma where we can't give these people nothing. They're dying or they're suffering. And so we do the next best thing and we do our new drug and we compare the benefits. And this next best thing is also often something that is pre-approved, that's been around for a while, that we kind of know the effects and we know how to measure those things. There's another great ethical dilemma in this little example talking about birth defects. And so it's very important that for pregnant women, we treat them with the utmost caution because birth defects are something that, you can tweak something just a little bit with medication and it can cause big problems with this, which is why oftentimes you'll read and they'll say things like, contact your doctor if you're pregnant or nursing. And so those people we need to be particularly concerned about. So again, just because things weren't exactly perfect, placebo, it might be a necessary ethical dilemma that's trying to be avoided. So that's the process. And there are a lot of critiques there. Again, doesn't invalidate, but certainly something that we should question and understand. What I want to get to is a couple things about the critique, right? How can we critique these things and make interesting, sometimes completely invalidating the claim or the question being asked? And it's really to consider the source, right? The source. Where did this thing come from? And one of the big critiques that's oftentimes a good one that you'll hear many times just as a throwaway line, but who paid for the study? This is a fun little example here. The SRF, or the Sugar Research Foundation, sponsored its first CHD, or coronary heart disease research project in 1965, that was way back in the day, which singled out fat and cholesterol as the dietary causes of coronary heart disease and downplayed evidence that sucrose, which is just sugar, consumption was also a risk factor. The SRF set the review's objectives. The Sugar Research Foundation set the reviewers' objectives, contributed articles. They were like, hey, look, you should include this in your study as well, and received drafts, meaning they were like, the way you phrased this wasn't very friendly to our product. Right, you're a little harsh on the sugar stuff. Okay, I want you to just eliminate that paragraph. Right, the SRF's funding and role was not disclosed. I mean, when people reading the study, they were like, oh, okay, something about the SRF, but just ancillary. But their funding was not disclosed. So together with other recent analysts of sugar industry documents, our findings suggest the industry sponsored a research program in the 1960s and 1970s that successfully cast doubt about the hazards of sucrose, which is sugar, while promoting fat as a dietary culprit for coronary heart disease. And so oftentimes you hear this stated that, hey, look, foods that are high in fat are very bad for your heart, and sugar is kind of this ancillary, not big deal. I mean, that certainly is changing nowadays, but it's important, especially in the food industry, to understand that there are biases and there is tons of money at play. People often talk about big pharma or big pharmaceutical companies. There's also another fun phrase, if you want to get into it, of big sugar, of just how the sugar companies are promoting their own studies. And again, there are great, in moderation, great ways to understand these claims in these studies, but it's important that when we read a claim like fat as a dietary culprit for coronary heart disease, that we understand that, yes, it may be bad, but it may not be the worst thing, right? There might be bigger or more difficult causes at play here. So understanding those sources. The next one is probably one of my favorites, and that's where was the data collected? Where was the data collected? Here's a fun little example demonstrating why the source, right? Where does this data come from? Why it's so important to understand. For instance, if this question was asked to a general population, you might get a different answer. The question goes like this: is it dangerous to have radioactive material in an airport? You're like, in an airport, radioactive material? You're thinking people's limbs are falling off, cells are dividing, skin's eroding, not good for general population, right? The connotation is bad. Maybe, especially in an airport, you might think, radioactive, are we talking bombs? But if you're in a physics conference, again, it's a common known thing that in these conferences, at least when they think of radioactive material, they're like, hey, isn't that used for a lot of imaging software, like body scans? Yeah, it is. And so they're like, yeah, it's fine. It's okay. In fact, it is very normal all the time. It might be invasive. You might not like it, but it is definitely considered normal. And so it's very important to understand where the data was collected, because that can influence the outcome considerably. Another interesting point to point out when we talk about sources is, when was the data collected, right? Is this the 1960s versus 1990s? For instance, a fun question to ask yourself is, well, there wasn't such thing as cell phones back then, so I'll just write phone use. If I want to determine how many people were on their phone at a specific time, I'm going to get a dramatically different answer, 1960s, 1990s, and you could imagine nowadays. The next source, and I have a little example to go along with it, is who published the study. This gets a lot into kind of who paid for it, but who in particular is publishing. In fact, the gold standard is anything that is considered peer reviewed. Not only is it peer reviewed, but usually it has to be around for a while. Usually a year or two, and then it's like, okay, people have had time to review and to look at this study, and it certainly holds up the water, because if something's peer reviewed and it gets debunked, or people start to critique the studies, as we're learning here, eventually that study will be pulled down, or at least heavily criticized. And so then it'll be obvious to the reader to take it with a hefty grain of salt. Let me give you an example of it matters who published the study. A little example here. PepsiCo owner of Quaker Oats, right? Quaker Oats, delicious, great way to start the day off with some oatmeal. Commissioned a study in 2011 to test whether Quaker Oat hot oatmeal and its cold cereal, Quaker Oat Squares, were more filling than Honey Nut Cheerios, right? They got a big rival. They're like, hey, look, our oatmeal and our cold cereal, we're thinking is better than this cereal. The report found that oatmeal kept its study's participants, 48 of them, fuller for longer than Cheerios, but the results were mixed about the cold cereal. Pepsi-Cola chose only to publish about its hot oatmeal, omitting the mention about its cold cereal. According to the Association Press, the company said the cold cereal results weren't significant enough to warrant publication, weren't significant enough. There's this really fun term if you want to read about some statistical malfeasance called p-hacking. This is essentially what they did or what they engaged in here. They said, look, we're going to test two different things, our hot oatmeal and the cold cereal. Hot oatmeal came up great. Test was good. We can say with some statistical significance that our hot oatmeal keeps people fuller longer than Cheerios. But for the cold cereal, again, they didn't get a statistical significance. And so all p-hacking is that you leave out the bad stuff. You leave out your failures. Oops. That you leave out your failures. Because it is a failure, right? It's kind of embarrassing to say, look, we found this. Again, it's not that one is better than the other with the cold cereal. It's just that we can't say that it's significantly better. P-hacking, again, a great term if you want to look up how to p-hack or what is p-hacking. There's some great videos that they're discussing exactly this concept where we need to determine, look, who published the study, who is in charge, and certainly it can lead to some misleading information. Good. There are some other examples. I want to get into more of how we build these questions out, in particular, how we question a claim. There are many headlines that you read either on your phone, on newspapers or magazines, things like this. I want to focus on this one right here. It says top 10 things to make you happy. All right, you might read that and go, oh, I want to read this. I'm interested. What can make me happy? But what's very important to understand is, wait a minute, what do they mean by happy? Because there are a lot of different things they can mean by happy. They could be talking about financial success, right? Instead of asking them, hey, are you happy? They could just look at your salary and say, hey, look, these people are really rich. They must be happy. And measuring these things out, instead of 10 things that make you happy, it could say 10 things that make you wealthy. And again, it might depend on how they measure that. It might be your family life, right? They might measure that based on, look, are you in your family? Do you have a family unit around you? They might measure happiness in a relationship standpoint, that they might be looking at, hey, look, 10 things to make your relationship better or happier, right? It really depends on what they mean by happy, because there are a lot of different perspectives or viewpoints on what we view as happiness. In the same way, it's important that when we read claims on products, we are very suspicious. Consider this study question. Which toothpaste keeps your mouth most, here's the critique, healthy? Which toothpaste, and you'll see this oftentimes, they'll say, hey, look, keeps teeth whiter, or they'll say things like, this is a healthy toothpaste for you. But it's often important to understand, look, what do they mean by healthy? Because there are many different questions that you can come up with. For instance, being healthy can talk about having fewer bacteria, but there are some good bacteria in your mouth that help either with dry mouth or help with breath. And so it's important that you don't kill everything in your mouth. Your mouth is a living part of your body. It's important that you have some good organisms in there. So maybe we change it and we say, okay, look, we wanted to define healthy as having less harmful bacteria. And that's something that we can measure. But maybe you're like, look, I don't really care about the bacteria. I don't really care about my breath being smelled like popping them in. What I want is whiter teeth. That's what I want to define as healthy. Okay, well, if that's how you want to define healthy, that's what the study can focus on. You can do some kind of longitudinal study where we talk about healthy as contracting fewer cavities, or maybe just something as simple as people who use our toothpaste spend less at the dentist, and that's how we can measure health. And so it's important that when we read claims, yes, more healthy, maybe the claim is something as simple as whiter teeth, that we understand that those claims come with caveats, right? What do we mean by happy? What do we mean by healthy? And we can pick apart those claims and critiques by simply asking interesting discussion questions in that regard. Let's do an example, similarly, debunking this claim. Consider the statement found in a popular shampoo bottle. Let's say it says something like, makes hair 60% smoother. what our task is to name some of the questions that would help you determine the validity and the applicability of that claim. Validity, meaning is it even valid, and applicability, meaning, hey, look, who does this even apply to, under what circumstances? I have some examples that I want to talk about. So it says make hair 60% smoother. All right here, 60% smoother. Then what? Right? What in the world are they comparing this to? 60% smoother than a rock, right? What are we comparing this to? It's important to understand where these things come from. Especially when we look at hair, we're like, look, under what conditions need to be met to make this 60% happen? So I'll say conditions, question mark, what to do? What do we need to do in order to make this 60% smoother a reality? Another thing, they're actually giving us a quantifiable number, right? 60%, but how was smoothness measured? How did they measure that? This gets into a fun little idea. Did they just measure one hair? Did they have somebody touch the hair and then from that determine its softness, right? What are we talking about here? How is it measured? This is something that's tough. Here we go. More questions, and especially for anybody who has more interesting, more fluffy, curly hair. Maybe you're like, look, 60% smoother, but on what hair types? I think this has gotten much better nowadays, but back in the day, it was always just, hey, look, one product was made for one specific type of person, and that was the best you got. But the beauty of competition is now there's a billion different shampoos, and some even are very particular. It's like, hey, this is for curly hair, this is for, X hair, this is for whatever, and so on and so forth, and you can pick your fancy. And so we have all these different conditions. 60%, what are we talking about here? Another fun one, this will be the last one that I'll mention here, is when we say 60% smoother, are we talking about weather? Does weather have a play? We'll say, look, like under what weather? Under what weather? Right? For anybody who has particularly difficult hair, you can notice, hey, look at this, shining bright outside and it's nice and dry. My hair is going to stay just the exact same. For others, if it's humid and raining outside, you go outside, your hair is instantly going to fail. That smoothness is going to degrade very quickly. So it's important to understand, again, what conditions this makes hair 60% smoother. And these are just some of the example questions to critique that claim. Good. Let me go through real quickly another avenue of critiquing a study. This is a fun one. It's oftentimes very important to understand, look, does the data you're even talking about, does it support your conclusion? Does it even relate to your question? Most often the answer is yes, but certainly there's sometimes a mismatch. Let me show you an example. Say maybe there's a headline that reads something like, most Americans don't like to see pajamas in a grocery store, right? They're like, look, it's unprofessional. I'm here. I put on pants. Can we please all put on pants that aren't pajamas? That can be a question that's posed. And say maybe the results of the headline were reported that 60%, that's certainly most, don't like to see, while 30% don't mind. Now, some of you, more mathematically engaged, are looking at this and saying, hey, wait a minute, 60% plus 30% is equal to 90%. But how is that the case? Well, there's actually two things at play. The first one is that means that 10% of respondents weren't sure, or at least the responses weren't sure, right? You might ask somebody, hey, how do you feel about people wearing pajamas in this grocery store? And they go, well. And you're like, well, okay, thank you very much. And you write down the information, right? It's not determined whether or not they dislike or don't mind at all. And so oftentimes you'll see that error or that fluctuation involved, that you get responses that you're not sure how to categorize that. Even worse off, though, is that oftentimes in these studies, especially these observational convenience studies where I'm just standing outside asking questions, is that oftentimes people don't respond, right? They're busy. They're walking through. They're like, look, I got to get to my car. I left my dog in there. I'm going real fast. And so oftentimes you'll get a huge bias. In fact, it's called a non-response bias of people who are just busy or they're not interested in talking, right? These are the busy individuals, or maybe they're the introvert people. They're like, look, I don't want to talk to a stranger with a microphone or with a clipboard. And so it's important to understand that that might influence, right? We talked previously about different sampling techniques and how one can be worse than the other. These busy people might sway a certain way. Maybe busy people who are more onto the business, maybe they're more just tunnel visioned and they're like, look, I don't care what people are wearing. I don't even care if they're wearing clothes, right? I'm just to the grocery store and gone. But those people might be more proper. Maybe they're thinking, hey, look, I need to see everybody wearing real clothes. In fact, a suit and tie should be the new standard. Okay, we don't know, because the fact of the matter is we didn't talk to them. And so it's very important to understand that in many of these, there's a non-response bias and there's usually a gap of people who respond, but it's not sure how they feel about a certain case. Non-response bias. This is the last example I want to talk to you about, critiquing a study and oftentimes how questions or information can be misleading. This one gets goofy. What is wrong with this study? Here's the study. Let's say there was consider a 14-year-old who reportedly conducted a science fair project in which he urged people to sign a petition demanding strict control or total elimination of a chemical. All right, this chemical was dihydrogen monoxide. After listing its detrimental properties, he asked 50 people if they supported a ban. He's like, look, let's ban this chemical. All right, it's like, what do they call it? Hay fever, or this like evil chemical that they're trying to get rid of. Some of the detrimental properties include it's colorless, it's odorless, it's tasteless. It kills uncountably thousands of people, oftentimes by accidental inhalation. If you get this in your system, sometimes it can cause serious damage. Prolonged exposure to its solid form, it can cause some serious tissue damage. Sometimes you're not even going to come back from it. It's very detrimental in its solid form. It's also known as hydroxide acid, which is a major component in acid rain. All right, we don't like that. That's not a good thing. It kills off a lot of grass and plants and certainly can be harmful for your skin. Let me skip down a little bit down here. It accelerates corrosion on rust and metals. In fact, if you leave this on metals, oftentimes it can be completely detrimental and ruin a project or a material that you may have. And so it's very important. So we're reading this as 14-year-olds asking these questions. And a lot of people are like, oh my gosh, ban it right away. We don't like it. It's no bueno, not good. But something important, maybe for you chemistry people or some people who are more informed, I want you to look at this real quick. This dihydrogen monoxide. Di is just a fancy word for two. Hydrogen is often written as H. Mono is just a fancy word for one. Oxygen is O. So if I put this together, oftentimes written H, I have two of those hydrogens, dihydrogen monoxide. Oxygen, I have one of those, whereas it's more properly written water. Yeah, water has all these properties, right? If it's cold, if it's in ice, solid form, and you put it on your tissue, or more appropriately, if you laid in the snow for hours on end, yeah, you'd have some frostbite damage and possibly not come back from it. Acid rain, are you kidding me? It's the water part in the acid rain. Accelerates corrosion, yeah, that one might have been a dead giveaway. If you leave water, especially mineral water, on metals, oftentimes it'll cause oxidation and rust. And so it's important that when we look at these studies, yes, there are things to critique. So let me wrap up with this. That when we're critiquing studies or processes, we have different avenues of approach. We can look at the process. Again, sometimes it's unavoidable that when we don't do placebos, there's an ethical dilemma at play. And whether or not that ethical dilemma is valid is a point for a conversation. We can also look at the critique, that when we ask these questions, right, what do they mean by these questions, or maybe who's publishing the result? And then lastly, oftentimes we can have misleading information. There could be a non-response bias. Maybe the information that we're giving individuals is very confusing. And so it's important that when you read studies, when you read facts, when you read claims, that statistics is not about ignoring or absorbing everything. It's not this one or the other. In statistics, there is a huge area for gray, that when we look at these questions and we ponder them, we say, okay, look, some good, some bad, and everything's with a grain of salt. But a true statistician takes claims and takes these things and can determine by or with how much salt to take these claims. And so it's important that we understand how these things are conducted and how to properly critique them. If you enjoyed the video, I appreciate the time you put into it. And until next time.